We already know that division is about splitting a total into equal groups. If you have 6 cookies and divide them by 3, you're asking, how many cookies does each person get? But what if you divide by a fraction? If you have 6 cookies and divide them by half, you're asking a different question. How many half cookies can I get out of the total 6 cookies? Dividing fractions helps us answer these kinds of real-world how many parts fit questions. The answer to any division problem is called the quotient. In grade 6, we focus on interpreting what the quotient means when we divide fractions. When you see A by B divided by C by D, you are mentally asking, how many times does the fraction C by D fit inside the fraction A by B? The quotient tells you exactly how many groups of the divisor fit into the dividend. Sometimes the answer is a nice whole number, and sometimes it's another fraction or mixed number. Before we can divide, we need to understand the concept of a reciprocal. The reciprocal, also called the multiplicative inverse, is what you get when you simply flip the fraction. The numerator becomes the denominator and vice versa. For example, the reciprocal of 3 by 4 is 4 by 3. Why is this important? Because any number multiplied by its reciprocal always equals 1. This property is the mathematical reason the division method works. The actual procedure for dividing fractions is much easier than it sounds, thanks to a simple memory trick called keep, change, flip, or KCF. You keep the first fraction exactly as it is. You change the division sign to multiplication. And you flip the second fraction, meaning you use its reciprocal. After these 3 steps, you've turned a complicated division problem into an easy multiplication problem. Let's look at example 1. We have half a pizza, 1 by 2, and we need to divide it among 3 friends. We write 3 as the fraction 3 by 1. Now we use KCF. We keep 1 by 2, change to multiplication, and flip 3 by 1 to 1 by 3. We multiply across. 1 times 1 equals 1, and 2 times 3 equals 6. The result is 1 by 6. This makes sense. If you share half a pizza with 3 people, each person gets 1/6 of the whole pizza. Example 2 is the opposite. 3 divided by 1 by 2. This asks how many half cups fit into 3 full cups. First, we write the whole number 3 as 3 by 1. Now we apply KCF. Keep 3 by 1, change to multiplication, and flip 1 by 2 to 2 by 1. We multiply. 3 times 2 equals 6. The answer is 6. If you have 3 cups of water, you can fill a half-cup measure exactly 6 times. Now for a true fraction divided by a fraction in example 3. 2 by 3 divided by 1 by 6. We want to know how many 1 by 6 slices fit into a 2 by 3 chunk. We use KCF. 2 by 3 stays. The division changes to multiplication, and 1 by 6 becomes 6 by 1. Our new problem is 2 by 3 times 6 by 1. Multiplying gives us 12 by 3, which simplifies to 4. 4 1/6 pieces fit into 2/3. Here's a tip that will save you a lot of time. Simplify before you multiply. After you do the keep, change, flip step, always look at the numerators and denominators diagonally. If you see common factors, you can divide right there. For instance, in our last problem, 2 by 3 times 6 by 1, we could divide the 3 and the 6 by 3. This simplifies the numbers before you even multiply, making your final product easier to manage. Let's use the simplification tip in example 4. 5 by 8 divided by 1 by 4. After KCF, we get 5 by 8 multiplied with 4 by 1. Look diagonally. The 8 and the 4 share a factor of 4. We divide 8 by 4 to get 2, and 4 by 4 to get 1. Now we multiply the simplified parts. 5 by 2. Finally, we convert this improper fraction to a mixed number, 2 1 by 2. Simplifying early ensures you don't have to simplify a big fraction at the end. When a division problem includes a mixed number like 2 1 by 2, there is one crucial step you must do first. You must convert the mixed number into an improper fraction. 2 1 by 2 becomes 5 by 2. You can only use the keep change flip method once both numbers are written as simple fractions. If you forget this step, your answer will be incorrect, so always check for mixed numbers first. In example 5, we divide 1 by 3 divided by 1 by 6. We start by converting 1 by 3 to the improper fraction 4 by 3. The problem is now 4 by 3 divided by 1 by 6. We apply KCF, 4 by 3 times 6 by 1. We can simplify the 3 and the 6 by dividing by 3. That leaves us with 4 by 1 times 2 by 1, which equals 8. So 8 1/6 parts fit inside 1 and 1/3. Example 6 is a bit trickier. 9 by 10 divided by 1 4 by 5. Again, start with the mixed number. 1 4 by 5 is 9 by 5. Now KCF, 9 by 10 times 5 by 9. Here, we have two opportunities to simplify diagonally. We can cancel the 9s, and we can divide the 10 and 5 by 5. This leaves us with 1 by 2 times 1 by 1. The final answer is simply 1 by 2. When you encounter a word problem, you need to interpret the question correctly to set up the division. Many division of fractions problems fall into one category, finding the number of equal groups. You are asked, how many groups of this size can I make from this total amount? Always set it up as the total amount, or the dividend, divided by the size of the group. Here's a word problem. A chef has 5 pounds of flour, and each recipe uses 1 by 4 pound. How many recipes can he make? The total amount is 5, and the group size is 1 by 4. We set it up as 5 divided by 1 by 4. Using KCF, we get 5 by 1 times 4 by 1, which equals 20. The chef can make 20 recipes. It makes sense that dividing by a small fraction gives you a larger whole number answer. Let's try example 7, where the total amount is a fraction. Maria has 3/4 yard of ribbon, and she needs 1/8 yard for each gift. How many gifts can she wrap? The question asks how many groups of 1/8 fit into 3/4. We set up the problem as 3/4 divided by 1/8. Using keep change flip, we get 3/4 multiplied by 8 over 1. We can simplify the 4 and 8 by dividing both by 4. This leaves us with 3 times 2 in the numerator, which equals 6. She can wrap 6 gifts. This means the total amount, 3/4 yard, contained exactly 6 1/8 yard pieces. The other major type of fraction division problem is finding the size of each part. You are told the total amount and the number of parts it's being split into, and you have to find the size of those parts. The setup is the total amount divided by the number of parts. Since the number of parts is a whole number, you just write it as a fraction over 1 before you use KCF. Let's look at example 8, a problem about finding the size of parts. A 4-mile racetrack is divided into 5 equal sections. How long is each section? The total distance is 4 miles, and the number of parts is 5. We set it up as 4 divided by 5. When you write that as a fraction, it's simply 4 over 5. You don't even need to use KCF here, because the fraction bar means division. So each section is 4/5 of a mile long. In example 9, we are sharing a total amount that is a mixed number. A 2 1/2 gallon container of milk is shared equally among 10 people. How much milk does each person get? We set up 2 1/2 divided by 10. We must first convert 2 1/2 to the improper fraction 5 over 2. Now we use KCF, 5 over 2, multiplied by 1 over 10. We can simplify the 5 and the 10 by dividing by 5. That leaves us with 1 over 2 multiplied by 1 over 2, which is 1 over 4. So each person gets 1/4 of a gallon of milk. Let's quickly review the checklist for fraction division. First, make sure you convert any mixed numbers to improper fractions. Second, use KCF. Keep the first fraction, change the sign to multiplication, and flip the second fraction to its reciprocal. Finally, always try to simplify diagonally before you do the final multiplication. Follow these 5 steps every time, and you'll solve any fraction division problem correctly. Here is your final challenge problem to solidify the rules. 3 1/3 divided by 5/6. Think through the steps. First, convert the mixed number 3 1/3 to the improper fraction 10 over 3. Second, use keep change flip, 10 over 3 multiplied by 6 over 5. Now we simplify. We can divide the 10 and the 5 by 5, and we can divide the 6 and the 3 by 3. That leaves us with 2 times 2, which equals 4. 4 5/6 pieces fit into 3 1/3. You are now experts in dividing fractions.